Munich, Germany. Franz Josef Strauss Airport. The second biggest airport in Germany is still very busy at the end of the day. The two parallel runways are being used by departing and landing aircraft. To test our pilots in the simulator, we have put a jumbo jet on the same runway to which the approach is to be carried out. An aborted landing is called a go-around. It may be ordered by an air traffic controller, but of course, pilots themselves may also decide to abort a landing if it couldn't be carried out absolutely safely. Since a go-around maneuver has to be performed at a very low altitude, perhaps only seconds before touchdown, there is simply no time for checklists, questions, or hesitation.
Gear down, flaps 15.
Shortly before touchdown, but no later than passing the decision height, the captain should announce his intention by saying, "landing" or "go around." Depending on the announcement, both pilots will know what to do next.
From the inside.
When going around, the most important thing is the transition from landing to takeoff as quickly as possible. The first step is to raise the nose of the airplane and start a climb, and increasing engine thrust by moving the throttle levers forward to speed up. Flaps should be set from 30 or 40 degrees, used for landing, to 15 degrees, which is suitable for takeoff.
Landing checklist. Landing checklist. Engine start switches. Continuous. Speed brake is armed. Landing gear down. Flaps 30, green light. Landing checklist completed. Runway is blocked. Go around. Go around. Flaps 15. Flaps 15. Positive. Gear up.
Flaps are set to 15 degrees, and the landing gear must be retracted to avoid the drag caused by its huge wind resistance.
To level off. Flaps 5.
Safety of flying is best described by the fact that, although during their entire career, pilots never, or very rarely, have to go around for real, they spend a lot of time practicing these procedures to be able to act routinely should a go-around become necessary.
And we have taxi clearance. Commencing taxi.
Pilots regularly train for what to do in case of an engine failure. Although the possibility of a perfectly maintained engine to fail is extremely low, pilots still have to prepare every takeoff in such a way that no engine failure can ever catch them off guard. In terms of engine thrust, one of the critical phases of flight is takeoff. It is in this phase of flight that an engine failure or any significant loss of power can cause the biggest problems. Takeoff is performed according to a very detailed procedure. Pilots must set and check everything and confirm the procedures with each other once again while taxiing to the runway.
Departure runway 31 left, normally 400 down of 1001 speed 220. Any failure or severe failure before V1 I will reject. Any failure after V1, making the left-hand traffic circuit, climbing 3000 feet or any other advised by ATC. In case of engine fire, no action required until passing 1500, only silence the bell. V1 125, rotate 125, V2 129er. Bod of 3 Delta SID.
Check. I have no questions.
The pilot in control has to keep the airplane on the runway center line, occasionally looking down at this instrument to check the speed, while his co-pilot should monitor the engine parameters. The captain keeps his hands on the thrust levers to be able to act promptly if necessary. During the takeoff procedure, call-outs are made about engine power and speed. The three most important speeds that need to be calculated before each takeoff are V1, VR, and V2. V1 is the decision speed below which a crew can decide whether to continue the takeoff or abort it. Before V1, the aircraft can still be stopped on the runway safely, whereas beyond this speed, the only option is to take off, as the plane couldn't be stopped on the remaining runway.
My trust, my control, your ATC.
The main engine parameters are displayed in the middle of the instrument panel. The left column of gauges shows the data of the left engine, while the right column indicates the operation of the right engine.
Takeoff thrust set. 80 knots. Cross check. V1.
Almost immediately after V1 comes the next important speed, which is VR. At this speed, the wings can generate enough lift for the aircraft to become airborne. Another call-out, rotate, is heard in the cockpit.
Rotate.
At this point, the pilot flying slightly pulls the yoke to raise the nose.
Positive rate.
Gira.
After takeoff, the aircraft should accelerate to and pass another speed called V2. It is the minimum speed at which flying remains safe, even if one engine fails.
Set on 1 speed 220. Flaps 1.
Let's see how our pilots can handle an engine failure in the simulator at such a critical moment as takeoff. taxiing at Ferihegy Airport in Budapest.
Takeoff. Lights are on. Before takeoff checklist. Flaps.
5 green lights.
Before takeoff checklist complete.
Everything looks fine. However, we are going to simulate an engine fire shortly before reaching V1, the decision speed.
Left side clear.
Right side clear.
You have the control, my ATC.
I have control.
Stabilized.
Takeoff.
Check. Engine fire, stop.
Just a couple of seconds pass between the fire warning and bringing the plane to a complete stop. Let's now take a closer look at the steps involved in an aborted takeoff. Before takeoff, the rotating switch of the automatic braking system in the middle of the main instrument panel should be set to RTO, which stands for Rejected Takeoff. This is also included in the checklists.
Auto brake. RTO.
RTO arms the automatic brake system to apply maximum braking to the wheels when the thrust levers are suddenly pulled back to idle and the aircraft is rolling at high speed. Before taking off, the pilots once more confirm their roles.
You have the control, my ATC.
I have control.
During the takeoff roll, the captain sitting on the left keeps his hand on the throttles, ready to abort the takeoff immediately if necessary. The lights in the cockpit have different colors. Blue indicates the operation of electrical systems and valves. Green lights refer to configuration, such as when landing gear and slats are deployed and locked in their correct positions. Red lights call for immediate action, such as in case of fire. Failures that do not require prompt action are indicated by amber warning lights. There are 2 buttons and a set of warning lights in front of each pilot. The red Fire Warn button is lit when fire is detected. The amber Master Caution button indicates conditions that do not demand prompt action. Pressing the button clears the current warnings, while pressing it again recalls the active indications. Since the aircraft still hasn't passed the V1 decision speed, the captain decides to abort the takeoff. This decision is made in less than 1 second.
Engine fire, stop.
For an aborted takeoff, the pilot must move the throttles to idle and turn on the thrust reversers. The thrust reverser deflects hot air generated by the engine and, as its name suggests, reverses the direction of thrust, thus providing efficient braking while the aircraft is rolling at high speed. At the same time, the automatic braking system engages, providing maximum braking power to the wheels. Large control surfaces called spoilers deploy from the top of the wings to reduce lift, making the main wheels touch the tarmac more firmly, which improves wheel braking efficiency.
Most következő részben azokat az eljárásokat és tevékenységeket fogjuk gyakorolni pilótatársammal, amik egy felszállás közbeni hajtóműtűz esetén kerülnek elő. A tűz önmagában a hajtóműnél is elég veszélyes, mindkét hajtóműre és a segédhajtóműre is van tűzoltó berendezésünk. Hogyha ez a felszállás közben kis sebességnél történik ez a tűz, akkor ugye van még elég pályahossz, hogy megálljunk, azonban ha egy bizonyos sebesség után történik, akkor már csak a levegőbe tudunk menekülni. Mivel az egyhajtóműves repülés különösen felszállás után kis magasságban nagyon veszélyes, ezért elsődleges az, hogy a repülőgépet vezessük és az uralmunk alatt tartsuk, és a tűz oltása csak ezután következhet, miután egy biztonságos magasságot elértünk már. Ez az a tevékenység többek között, amit a pilóták nagyon sokszor begyakoroltak, és már szimulátor képzésük során a rutin műveletnek számít.
In simulators, pilots are thoroughly trained for engine failures after V1 at takeoff. After passing V1, the takeoff can't be aborted because the aircraft is moving too fast to be stopped safely on the runway. Let's see how our pilots can deal with simulated engine fire occurring after the V1 decision speed.
Takeoff thrust set. 80.
Cross check.
V1, rotate. Positive rate. Continue.
Relapse, silence the bell.
The pilots hardly even seem to notice the warning. In fact, however, they are fully aware of the situation, and they also know that the most important thing now is to fly the aircraft and gain some altitude.
400.
Heading select.
For safety, the entire takeoff procedure is designed to ensure that the aircraft will be able to climb at V2, the minimum speed should one engine fail. But flying this type of aircraft with only one engine operating is very hard because of what is called asymmetric thrust. The jet engines mounted under both wings normally produce equal thrust. If, however, the thrust of either engine decreases, or, in case of an engine failure, thrust becomes asymmetrical. At a safer altitude, the cockpit becomes a really busy place.
Set.
Start APU.
APU stands for Auxiliary Power Unit, and it's a small jet engine in the tail of the aircraft. It does not move the airplane, but generates electricity and compressed air. In normal conditions, the APU is not needed in the air, because each of the two main engines can generate enough power. With a failed engine, however, only one generator remains operative, so the APU has to be started as a safety backup generator. The next step is to identify the failure.
We have engine fire number 2.
Engine fire, severe damage or separation. Memo items, please.
Apart from charts and normal checklists, it is also compulsory to have all the emergency checklists on board, which contain procedures for all possible failures. Pilots can use these non-normal checklists to make sure that they can handle any emergency situation. What's more, they can make sure to follow the steps in the right order. Some procedures need to be performed by heart. Engine fire, for example, demands immediate action. Checklists will come a bit later. It's essential that the pilots work together and check each other in the next few moments. They have to shut down the engine on fire, and it would be a fatal mistake if they accidentally shut down the good engine. To avoid any mistake, pilots announce and confirm every action to each other before doing it. To completely shut down an engine on fire, the pilots first have to turn off the automatic thrust system, then pull the affected throttle lever back to idle, and finally turn off the fuel with a switch aft of the throttles.
Auto throttle disengage.
Disengage.
Shutting down the good engine has to be avoided at all costs. So while one pilot is busy shutting down the wrong side, his co-pilot keeps his hand on the controls of the good engine. Watch this.
Thrust lever number 2 close.
Close, I confirm.
Number 2 start valve cut off.
Cut off.
The fire extinguisher is operated by the controls next to the throttles. Fire in the engines is extinguished by pulling and rotating either of the two red handles. When there is no fire, you can't move the handles, but when fire is detected in either engine, the red handle on the corresponding side is illuminated, and the fire bell goes off. There are two bottles filled with fire extinguishing agent and connected to both engines. In our simulated emergency, the right engine is on fire, so the right handle will have to be pulled and rotated. If the fire can't be put out with the first bottle, the other bottle can also be used by turning the handle to the other side.
And engine number 2, pull and rotate. Fire switch.
Rotate.
Recall items completed. Fire extinguished.
I confirm.
1500.
Speed up. Flaps 1.
210 set. And speed is good for flaps up.
Flaps up. And engine fire, severe damage, separation checklist, please.
The aircraft is flying at a safe altitude. The fire has been put out. So far, the pilots have been working by heart. But in aviation, people want to be really sure, and that's what checklists are for.
Engine fire, severe damage, separation checklist. The recall items. Auto throttle disengage is disengaged. Thrust lever close, closed. Engine start lever cut off, cut off. Engine fire warning switch, rotate, rotate. If engine fire warning switch remains illuminated, not our case. Isolation valve switch close, confirm close.
I confirm close.
Pack switch affected side, which is right side off, confirm
Right side
right
off.
pack off. APU bleed air switch off, it's off. APU is available for the bus.
On bus.
On bus. APU start and on bus. It started and on bus. Fuel balance not required. Transponder mode selector TA
Set TA.
set. If wing anti-ice is needed, it's not needed. Plan to land at the nearest suitable airport.
Although this aircraft can also fly with only one engine, it wouldn't be safe to do so for a long time. Our pilots make a decision to return and land as quickly as possible.
Okay, we make a turnaround.
Turn around and plan to use runway 13 right if
Copy it.
available.
Accomplish one engine inoperative landing checklist.
In an emergency, it's crucial to use checklists for each phase of the flight. Pilots that are too nervous or tense while following emergency procedures might easily forget to complete some routine tasks.
Okay, standing by for the checklist. After takeoff checklist.
After takeoff checklist, please.
Engine bleeds both sides on. Packs, left auto, right pack off. Landing gear up and off. Flaps up, no lights. After takeoff checklist completed. Set both sides.
With only one engine working, landing must be carried out with flaps 15, instead of the normal setting of 30 or 40 degrees of flaps. The 15-degree position is an ideal compromise between lift and drag. Fully deployed flaps not only generate more lift, but they also cause more drag, slowing down the aircraft, and now there is less engine power available than in a normal situation. But there is a price to pay for landing with flaps 15, a somewhat higher final approach speed than when landing with flaps 30 or 40. A higher flap setting would require more engine power, but due to the asymmetric thrust of the left engine, flying the aircraft would be more difficult. Therefore, pilots have to use flaps 15 for landing, and choose a slightly higher final approach speed. Pilots add at least 5 knots to the speed calculated by the flight computer.
Checked.
Flaps 15, landing. VREF 129er, target speed 134.
134, okay, confirm.
Set VREF 15, set. And one engine in operative landing checklist completed, except deferred items.
Okay.
Too low flaps. Too low flaps.
At lower altitudes, the aircraft's automatic systems warn of flaps position. But now, this warning should be ignored and muted with a special switch.
Flaps inhibit, please.
Too low flaps.
Some more checklists, and the approach briefing.
Okay, descent checklist. Recall was checked. Anti-ice is off. If additional go-round thrust is desired, it's not our case. Auto brake. 2.
2.
Ground proximity flap inhibit switch. Flap inhibit is set. Landing data VREF 15. Set 129. Target speed 134.
134.
Minimum
Okay.
650 for that runway.
The approach briefing can't be complete without confirming the go-around procedure as well.
Go-round procedure. In case of a go-round, flaps 1.
Okay.
2500.
As soon as we have positive rate, gear up.
Okay,
As
set
usual.
flaps 1, please.
Flaps 1. Okay, descent checklist completed. Approach checklist. Altimeters 1015.
Thank you.
Set and cross-checked. Approach checklist completed. Standing by on landing checklist.
Okay. Flaps 5.
Flaps 5. You are good on slope now.
Gear down. Flaps 15.
Flaps 15. Target
1000.
speed 134. And landing checklist. Engine start switch, operating side. On. Speed brake, armed, landing gear down. Flaps 15, green light. Landing checklist completed.
Thank you.
We have landing clearance.
$500. Wide slope. $400. 300. 200. Approaching minimums. 100. Minimums. 40, 30, 20, 10.
Speed brakes not up.
Speed brakes up now. Reverse around locked.
At 60 knots.
A failure, such as fire due to an electric spark, might damage other systems too. In this case, pilots have to identify and sort out multiple failures. We have set the simulator to simulate wheel well fire in flight. The fire will damage one of the hydraulic systems, causing further failures. Our pilots should identify and handle all these problems, follow the right procedures, and then land safely.
We have fire.
Identify.
Wheel well fire.
Wheel well fire checklist,
Checklist.
and procedure, please.
Wheel well fire checklist. Okay. Wheel well fire checklist. Fires detected in the main wheel well. Observe extend limit speed 270. Reduce speed 250.
Reducing 250.
There is no fire extinguisher in the wheel well. In case of fire, the procedure is to lower the landing gear and simply let the strong rush of air put out any fire. Because of its huge wind resistance, the landing gear can't be extended at a very high speed. So the first thing is to slow down. On this aircraft, the gear can be extended below 270 knots.
As soon as we are under 270, gear down.
Extending the landing gear.
Okay, note, do not use FMC fuel predictions with landing gear extended.
Okay, I confirm.
If the landing gear must be retracted for airplane performance, leave the landing gear extended for 20 minutes after the wheel well fire warning light has extinguished. Okay,
Time check.
yeah, we leave it open and land as soon as possible.
The nearest suitable is Lima Zulu India Bravo or
Which is
destination.
Bratislava.
Yeah.
Okay, plan to land at Bratislava.
Speed is 280 and reducing. 270, gear down.
In our simulated scenario, the fire in the wheel well has damaged one of the aircraft's hydraulic systems, causing a leak.
We have master caution, hydraulics. We have loss of system B.
On the Boeing 737NG, many systems require hydraulic power, including the control surfaces, flaps, nose wheel steering, the wheel brakes, the thrust reversers, and even the autopilot. For safety considerations, the aircraft has 3 independent hydraulic systems called A, B, and standby, a backup system to operate the rudder. Hydraulic systems A and B each have 2 independent pumps to provide hydraulic pressure. One of the pumps is engine-driven, the other is electric.
Loss of system B checklist, please. Autopilot and
You have
auto-throttle.
control.
I have control.
Loss of
manual.
System B. Both System B hydraulic pump low pressure lights illuminated, accompanied by low System B pressure indicates loss of System B. Other indications include System B flight control low pressure light illuminated. And not yet, because we have still low pressure. System B flight control switch, standby radar. Confirm, System B.
Standby. I confirm.
And we have the low pressure light. System B hydraulic pump switch is off. Confirm.
I confirm off.
B switch is off.
Pilots should be fully aware of how the operation of the aircraft's other systems is affected by the loss of hydraulic system B. In this particular case, it's the flaps that require special attention, as they are normally driven by hydraulic system B. With the loss of hydraulic pressure, a backup electric motor should be used. But deploying the flaps with the electric motor takes more time.
Plan for flaps 15 landing.
Landing must be accomplished with flaps 15, which is also suitable for a go-around.
Flaps 15, VREF is 129.
Okay, 129.
Target speed 134.
134.
Plan to extend flaps to 15 using alternate flap extension, so it will take time. Alternate flap extension time to flaps 15 is approximately 2 minutes.
2 minutes, okay.
The drag penalty with the leading edge device is extended may take it impossible to reach an alternate airfield.
Okay.
We have 2.6 tons of fuel and we are just near Bratislava, so we
Okay.
can reach Bratislava. Loss of System B checklist completed. Expect deferred items. Descent checklist. Recall.
And checked.
Was checked. Okay, we have hydraulics
Yeah.
and flight controls. Okay. Auto brake 2. Ground proximity flap inhibit switch to flap inhibit. Approach checklist. Altimeters 1015 set cross checked. Alternate flaps master arm. Confirm arm.
I confirm.
And okay, standing by for flaps.
And flaps 1.
Flaps 1. Flaps 1.
Set speed 160 and flaps 5.
Flaps 5. Localizer capture.
Checked.
Runway heading 221 set. Glide slope capture.
Checked.
With the approach altitude 3000 feet set.
Checked.
Flaps 10.
Okay, set flaps 10.
Flaps 10.
Yeah, flaps 15.
Flaps 15. Target speed 134.
And landing checklist, please.
Flaps 15. Landing checklist. Start switches. Continuous. Speed brake is armed. Landing gear down. Flaps 15. Green light. Landing checklist completed. Meg fogjuk látni ezt a pályát a minimum előtt.
1000.
Checked. Runway inside.
$500. 300.
Runway inside.
200.
Contact landing.
100. 50. 40. 30. 20. 10. 10.
Speed brakes up.
Speed brakes up.
There's a run low.
$60.